Introduction to a lesson on the Chebyshev method and integration by parts. The history of both. The Chebyshev method for product integration was introduced by none other than Pafnuty Chebyshev. Chebyshev was a Russian mathematician from the mid-1800s, and he studied probability, statistics, mechanics, and number theory. Integration by parts was first introduced by Brooke-Taylor in 1715. Brooke-Taylor was an English mathematician, most famous for his work with the Taylor theorem and the Taylor series. Chebyshev method and integration by parts. What are they? Both are methods to solve complex integrals in which two functions are multiplied together, but they are very different methods. Chebyshev method deals with only integrals with two trigonometric functions multiplied together, while integration by parts deals with both trigonometric functions and non-trigonometric functions like e to the x or ln of x. Integration by parts. So in integration by parts, the integrands are the product of two functions, f of x and g of x. But to visualize this better, we are going to make this into the integral of u times dv. And the formula to solve integrals by integration by parts is the integral of u dv equals u times v minus the integral of v du. But what's u and what's v? So out of f of x and g of x, we will choose one to be u and the other to be dv. Which one is which? So set u to be the functions that, when differentiated, du is simpler than u, and set dv to the function that easily fits into integration rules. In other words, u should be easily differentiated, and dv should be easily integrated. To simplify this, your problems will be one of three situations: the integral of x to the n times e to the ax, or x to the n times sine, cosine, or tangent. And in this case, set u equal to the x function, and dv would be the e to the x or the sine, cosine, tan. The second case is x to the n times ln x, or x to the n times any of the arctrig functions. For this situation, dv is x and u is the other function. The third example is e to the ax times sine or any of the trig functions. And in this case, e is dv and the trig function is u. Examples of integration by parts. I'll do one example for each of the three situations. So example 1 is here, integral of x times e to the 2x dx. Set u equal to x. Take the derivative, du equals 1. dv is e to the 2x. Take the integral, v equals 1/2 e to the 2x. Now you plug everything into the equation like it's shown here, and you get the answer. Integral of x e to the 2x equals 1/4 e to the 2x times 2x minus 1 plus c. You can review this example on your own in my notes. And then situation 2. So the example is the integral of x ln x dx. So you set u equal to ln x, take the derivative, du equals 1/x, v equals x, and take the integral, v equals x over 2. Plug everything into the formula, u times v, x squared over 2 ln x, minus the integral of v du, which is x squared over 2 times 1/x dx. And then you clean everything up and get the answer. X ln x equals, the integral of x ln x equals x squared over 4 times 2 ln x minus 1 plus c. Okay, next example. Situation 3. The integral of e to the 2x times sine x. So these examples are more tricky because you have to do integration by parts twice, but I'll explain that once we get there. So you set u equal to sine x, take the derivative, du equals cos x, dv equals e to the 2x, take the integral, v equals 1/2 e to the 2x. Plug everything into the equation, and you get 1/2 e to the 2x sine x minus 1/2 times the integral of e to the 2x cos x. And you notice there that you have to do integration by parts again. So you set everything up to do integration by parts for e to the 2x cos x, and then you're going to plug it back in. So for this situation, u equals cos x, du equals negative sine, dv equals e to the 2x, v equals 1/2 e to the 2x. And you plug everything in, and you get this answer over here. Then you plug this answer back into the original, and you get 1/2 e to the 2x sine x minus 1/4 e to the 2x cos x minus 1/4 the integral of e to the 2x sine x. And notice that e to the 2x sine x is what you started off with, so you can just add that to the other side and solve for that integral right there. So you get add the 1/4 times the integral to the other side, and you get 5/4 integral of e to the 2x sine x equals this over here. And you multiply the 5/4 and simplify everything, and that's what you get. Okay, the Chebyshev method. And this method is only for solving integrals that multiply two trig functions. And the two questions that you'll get are dealing with the integral of sine to a power times cosine to a power, and the integral of secant to a power times tan to a power. And this is just a list of important concepts that you need to know to solve these problems. Okay, on to the first type. So when either the power of sine or the power of cosine is odd, save one factor of the odd power to the differential. And you'll understand why with the examples. So notice how cos x dx is equal to d sine x. So you just substitute that and treat sine x like x to a power and integrate it normally. So this integral equals sine cubed over 3 plus c. I'm going to skip over this example, but it's self-explanatory. When m and n are even, you need to use the reduction factors. So for cosine to the 4th x dx, you split it into cosine squared x squared, and you take out the 1/4 and leave this 1 plus cos 2x squared. Then you square this and spread it out and integrate this part, and that leaves you with the integral of 1 plus cosine to the 4x, and that you can just integrate normally, and it leaves you with this as the solution. For secant tan, when the power of secant is even, you save a square factor of secant x for the differential, because secant squared x dx is equal to d tan x. So in this first example, this would leave you with tan squared x d tan x, and when you integrate that, that's equal to tan cubed x over 3 plus c. When both powers are odd, save a secant tan, because that is equal to d secant x. So in this example, you get rid of the secant tan x for d secant x, and that leaves you with secant squared x d secant x. And that is secant cubed x over 3 plus c. And that's it for the Chebyshev method. Conclusion with real-life applications. So since both the Chebyshev method and integration by parts are methods to solve integrals, I'm going to talk about the real-life applications of integrals. Integrals have many applications in modern-day science and math. In physics, you can use integrals to calculate velocity, position, acceleration, center of mass, and calculate the trajectory of satellites. In medicine, you can use integrals to track the spread of a disease, which is very applicable to our situation right now with COVID-19. And in chemistry, you can use integrals to determine the rate of reaction.